All right, students, let's look at 6.2 and 6.3 really go hand in hand when we talk about conditions and properties of parallelograms. And that's why you'll notice on the notes uploaded on Google Drive, they are written out together. I don't want you to focus in too much on every single theorem. Okay, by all means, you do not need to write down every single theorem unless you really are up for it. It's not necessary something that you need to do. The biggest thing is to focus on what are the characteristics. Okay, we understand first of all in parallelograms it has the word parallel in it. Okay, so that means we have to have parallel sides, and this is identified right there at the very beginning. A quadrilateral with two pairs of parallel sides is a parallelogram. So we have opposite sides being parallel, stated right here. Opposite sides are being parallel. In addition to it being opposite sides are parallel, opposite sides are also congruent. Opposite sides are also the same length. AB is congruent to CD, BC is congruent to DA. In a sense, think of it as what we know about a rectangle, except a rectangle is been tilted a little bit in order to have this parallelogram. There is a proof you can look through. We do not need to focus in on the proofs too much. Looking at more properties, opposite angles. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Opposite angles are congruent. Now we know those four angles, angle A, B, C, and D, must add up to be, hopefully you said 360 degrees, because it is a four-sided shape. Okay, four-sided shape. If a quadrilateral, this is the next theorem, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Supplementary, that thinks back to the beginning of the school year, add up to 180 degrees. Consecutive angles, a red and a blue, red and a blue, red and a blue, those are next to each other. Adjacent angles, those are up to 180 degrees. And the last one, 6-2-4, is a quadrilateral. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Diagonals bisect each other. So AZ is congruent to CZ, BZ is congruent to DZ. They split each other in half. That's the biggest thing to focus in on. It also creates four little smaller triangles in there. Okay, so four smaller little triangles. So those are some properties of parallelograms. And then it kind of works through some basic questions here. If we look down here at question, to check it out in in quadrilateral KLMN, LM is 28. LM is 28. KN must be 28. It is across from it. What is the measure of NML? NML, well, if LKN is 74 degrees, its opposite must be 74 degrees. If we know that LN is 26, based off up here, LO must be half of it, which is 13. Just some quick check your conditions. Same thing up here. Couple of quick characteristics. We know that this side here must be equal to this side here. Set it equal and solve, which it does. In part A, this angle must be supplementary to this angle. They are next to each other. They angle A plus angle B, set it up, solve, and you get your angle measurement. So really it's straightforward algebra. We're just now, instead of working triangles, we're working with quadrilaterals, working with four-sided shapes. Question 3, parallelograms in the coordinate plane. It gives you 3 of the vertices, and it gives you a step-by-step walkthrough. Graph, slopes, using our slope formula, and then proving that they are congruent to or parallel to each other by showing the slopes are the same down here by 1/4 and 1/4. If we look at our 6-2 homework, starts with some definitions, starts with some quick facts, quick guess and checks, quick calculations, and then it has you doing a problem where you find the fourth vertex, but it walks you through it. Okay, it walks you through it. So, new information, you're assisted with the walkthrough, so do not be too concerned about the new information. And then there's a couple proofs on page 406, do not worry about the proofs. You can look through them by all means, but proofs right now are going to be put on the back burner. Conditions for parallelograms. These are, in a sense, to think about your converses. These are the opposites. Okay? Nothing's new. Nothing's different. All it is bringing it up in the other way. It says for 631, if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral must be a parallelogram. Okay? Of course it has to be a parallelogram. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. You get where I'm going. The only difference with this section here, and when it comes to the homework assignment, okay, is it's a little bit more using words, using logic, using, in a sense, proofs, but you're not actually doing two-column proofs or anything along the lines of that. You're writing out not as much algebra until you get down to questions 8 and 9 and 12. It's more or less putting and applicating what you have learned into some sort of thought. So 6.2 and 6.3 really work hand in hand. Again, do not focus in too much on what the actual conditions are. In page 413, it gives you a really good layout of what the conditions for parallelograms are. Don't worry about the theorems, okay? Do not feel like you have to write them down. They are just guidelines for your sort of questions. Go ahead, take a peek through these questions, and when we Zoom on Wednesday, we can clarify any major questions that you have. But I think using your previous knowledge of triangles and applying them into this very basic introduction into parallelograms for 6.1, 6.2, and 6.3, I think you will be very successful. Thank you, and let me know what questions you do have. Goodbye.